After getting the basic knowledge about input-output system, let's move to modes of input-output transfer. Data transfer between the CPU and input-output devices may be handled in a variety of modes. Some modes use the CPU as an intermediate path. Others transfer the data directly to and from the memory unit. Data transfer to and from peripherals may be handled in one of the four possible modes. 1. Programmed input-output. 2. Interrupt-initiated input-output. 3. Direct memory access or DMA. And 4. Input-output processor or IOP. Let's start with programmed input-output. In the programmed input-output mode, each data item transfer is initiated by an instruction in the program. Once a data transfer is initiated, the CPU is required to monitor the interface to see when the transfer can again be made. In the programmed input-output method, the CPU stays in a program loop until the input-output unit indicates that it is ready for the data transfer. Usually, the transfer is to and from a CPU register and peripheral. Other instructions are needed to transfer the data to and from the CPU and memory. Here, the input-output device does not have direct access to memory and the data transfer takes place under the direct control of the processor. The processor has to check input-output devices continuously, due to which it is unable to do another task frequently. Hence, this method is inefficient and slow. Let's take an example of input-output operations which involves a keyboard and a display device in the computer system. There are 4 registers available which are used during the data transfer operations. These registers are as follows: data in, data out, status, control. A program that reads one line from the keyboard stores that word in the memory buffer and also displays that word on the display. This example explains the programmed input-output mode in which the processor continuously checks and status flag to achieve the synchronization between the processor and an input-output device. We can see that the processor polls the input-output devices. Polling. Polling is also referred to as busy waiting. In this situation, when an input-output operation is required, the computer does nothing other than check the status of the input-output device until it is ready, at which point the device is accessed. It is sometimes also referred to as software-driven input-output, interrupt-initiated input-output. An alternative to the CPU constantly monitoring the flag is to let the interface inform the computer when it is ready to transfer data. This mode of transfer uses the interrupt facility. In the meantime, the CPU can proceed to execute another program. The interface, meanwhile, keeps monitoring the device. When the interface determines that the device is ready for data transfer, it generates an interrupt request to the computer. Upon detecting the external interrupt signal, the CPU momentarily stops the task it is processing, branches to a service program to process the input-output transfer, and then returns to the task it was originally performing. At least one of the bus control lines should be assigned for this purpose, known as interrupt request line. Whenever an interrupt request is initiated, an interrupt service routine is initiated. On the other hand, the processor must send an interrupt acknowledge signal to the device to inform that its request has been recognized so that it may remove its interrupt request signal. Interrupt service routines are handled in the same way as that of subroutines, but a subroutine performs a function when some running program called the subroutine. Interrupt service routine may or may not have anything in common with the current running program at the time interrupt service request is requested. These two are different programs and can often belong to two different users. Whenever an interrupt occurs, the information on the current running program must be saved. This information will be restored after the completion of interrupt request. The information that is saved and restored includes the condition code flag and the content of any registers used by the program or by the interrupt service routine. Saving the register content to memory increases the delay between the request for the interrupt being received and processor starts the execution of interrupt service routine. This delay is known as interrupt latency. The device which requests for an interrupt sometimes identifies itself directly to the processor. After getting the request, processor saves the content of currently running process and starts executing the interrupt service routine. This kind of interrupt is called vectored interrupts. If the processor is currently servicing a low priority device, only then an interrupt request of high priority device will be accepted. But if the processor is already servicing a high priority device and a low priority device requested for an interrupt, that will be either rejected or the device has to wait till the processor completes its execution with the high priority device. Thank you and see you in our next lecture. Unit 4, Topic 4, Video 1, Introduction to Computer Networks. When we want to communicate with someone, we do that by sharing some information with each other. The sharing can be local or remote. If two individuals want to communicate, then local communication comes into existence, which usually occurs face to face. But if persons are at some distance, then remote communication takes place. Components. A simple communications system is mainly divided into 5 components. 1. Message. The message consists of the data or the information to be communicated over the network. Some common forms of information are text, numbers, pictures, audios, and videos. 2. Sender. The device which sends the message is known as sender. The sender can be a computer, workstation, telephone, and many more. 3. Receiver. The device that receives message is known as receiver. It can be a computer, workstation, telephone, and many more. 4. Transmission medium. The physical path through which a message is transferred from the sender to the receiver is known as the transmission medium. It includes twisted pair wire, coaxial wire, fiber optic cable, and radio waves. 5. Protocol. A protocol is defined as a set of rules that govern communications between data. Without a protocol, two devices that are connected to a network but not communicating to each other, like two persons that are standing. First person is speaking French, which cannot be understood by the second person, who happens to be Japanese. Data representation. Data comes in different forms like text, numbers, images, video, and audio. Text. During communication, the text is transferred in the form of binary, which is represented as a bit pattern of zeros and ones. To represent various text symbols, different sets of bit patterns has been designed. These bit patterns are called code, and coding is referred to the way of representing these symbols. Unicode is the coding scheme mostly used to encode the text. It uses 32-bit representation for a character or a symbol. American Standard Code of Information Interchange (ASCII), developed by United States, which encodes first 127 characters in Unicode. Numbers. Numbers are also represented by bit patterns of zeros and ones. However, ASCII code is not used to represent numbers. The simple decimal to binary conversion is used to represent the numbers in the bit patterns. Images. Images are also represented by bit patterns of zeros and ones. An image contains pixels, which are known as picture elements, where each pixel is represented by a small dot. The pixel size depends on the resolution of the display device. For example, an image can be divided into 1000 pixels or 10,000 pixels. Better picture quality is displayed when 10,000 pixels are used to represent the image means better resolution, but the memory required to store the image will be more. Audio. Recording or broadcasting of sound or music is referred to as audio. By nature, audio is different from text, numbers, or images. It is continuous, not discrete. Even when a microphone is used to change voice or music to an electrical signal, it creates a continuous signal, not the discrete signal. Various different kinds of audio formats are available like MP3, WAV, OGG, and many more. Video. Recording or broadcasting of a picture or movie is referred to as video. It can be either continuous or discrete. Video produced by a combination of images is a continuous entity, for example, by a TV camera, or arranged to convey the idea of motion is a discrete entity. We can change video to a digital or an analog signal. Types of communication. Data flow communication between two devices can be simplex, half duplex, or full duplex. Simplex. In simplex mode, the communication between two nodes is unidirectional, as on a one-way street. Only one of the two nodes connected on a link can transmit data on the link. The other node can only receive the data. Keyboards and traditional monitors are examples of simplex nodes. Half duplex. In half duplex mode, each node connected to link can both transmit and receive, but one at a time. If any connected node is sending the data, the other node can only receive the data, and vice versa. Half duplex mode is like a one-lane road, with traffic allowed in both directions. When cars are traveling in one direction, cars going the other way must wait. Walkie-talkies and CB or citizens band radios are both half duplex systems. Full duplex. In full duplex, both stations can transmit and receive simultaneously at the same time. The full duplex mode is like a two-way street with traffic flowing in both directions at the same time. One common example of full duplex communication is the telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. Thank you and see you in our next lecture.